About 250 million years ago, long before dinosaurs roamed Earth, the largest extinction in Earth's history took place. This extinction, called the End Permian extinction, or the Great Dying, eliminated around 90% of marine species and 70% of terrestrial vertebrates. The theory that massive volcanic eruptions in the Siberian traps caused the Permian mass extinction originated from research in the late 1980s and early 1990s. Geologists recognized that the Siberian traps, a vast region of volcanic rock in modern-day Russia, were formed during the Permian-Triassic boundary, coinciding closely with the extinction event around 252 million years ago. The volcanic hypothesis gained momentum as studies on rock dating techniques and geochemical analysis of ancient marine sediments showed correlations between the timing of the eruptions and the rapid environmental changes that marked the extinction. The Siberian traps eruptions likely contributed to the Permian extinction through multiple cascading environmental and chemical processes. Here's a detailed breakdown of the main mechanisms and the chemistry involved. The first contribution that the Siberian eruptions provided to the mass extinction was the release of greenhouse gas emissions and global warming. The eruption released massive amounts of CO2 into the atmosphere. Volcanic activity can emit CO2 directly, but the magma from the Siberian traps also intruded coal and organic-rich rock formations, releasing additional carbon-based gases. Because carbon dioxide is a greenhouse gas, it absorbs infrared radiation, preventing heat from escaping Earth's surface, thereby increasing global temperatures. This prolonged warming created a hyperthermal event estimated to have raised ocean and land temperatures by at least 10 degrees Celsius, stressing ecosystems globally. The second factor leading to the mass extinction is ocean acidification. Because of the increased atmospheric CO2 dissolving in the ocean water, carbonic acid was formed. This increased flux of carbonic acid reduces pH levels, making the oceans more acidic. This acidification hinders calcifying organisms like corals and plankton, which rely on carbonate ions to build calcium carbonate shells and structures. A third factor providing evidence for the mass extinction was the ocean anoxia caused by increased global temperatures that reduced oxygen solubility in oceans. This resulted in widespread anoxic conditions where organisms were unable to thrive. Additionally, factors such as the release of excess methane, the release of toxic metals, and the prevalence of acid rain are all elements that could be predicted as the outcome of the Siberian trap eruptions. Each of these mechanisms likely worked in tandem to create a domino effect, destabilizing ecosystems and driving widespread extinction. The combination of CO2-induced warming, ocean acidification, toxic metal contamination, ocean anoxia, and methane release presented environmental changes that ecosystems could not adapt to quickly enough, leading to the collapse of marine and terrestrial life.